In this video, I want to continue to talk about real projective spaces. In particular, I'm going to talk about real projective one-dimensional space. In other words, I talk about RP1. And last time, I gave a motivation and intuition that RP1 is a circle by using one of the models. So here, I want to introduce another models which will help you to look at the space from a different perspective. So let's take a plane. And this plane is going to be given as R2 minus the origin, as we discussed before. And when I'm in my projective space RP1 is going to contain the points inside it, which is not are actually the points of my Euclidean of my Euclidean space of my plane. But the point here, whenever I'm going to pick some line L that goes to the origin, that line is going to be a point in my real projective space. And the idea is more or less a world that this projective space like encodes the idea. If I'm going to sketch another line here, let's call it L prime, we can see that this L and this L prime do not intersect here, but they're going to kind of intersect at the infinity. Because if I were going to take another, let's say that line like here, we can see these two lines, let's call them, I don't know, like L1 and L2. L1 and L2 in this case are going to intersect inside our Euclidean space. But if you're going to take two parallel lines, they do not intersect inside, but they're going to intersect on the boundary of our Euclidean space. And that boundary, in some sense, where they intersect is going to be exactly our RP1. So in other words, imagine this, you kind of, like when we work with projective space, we actually work with a projection. It's like you standing and you see the horizon, you see two lines which are parallel, and they're going to intersect these lines at the horizon. So for example, you look at the road, so they intersect on the boundary on the horizon. If you're going to come back here and you will imagine that in some sense, you like looking where they're going to intersect. You can say they're going to intersect like somewhere here on the horizon. And every line that is going to be parallel is going to be intersect there. But for now, if you're going to rotate a little bit your lines, so you're going to change the angle, then they're going to intersect at this point. And whenever you're going to rotate your lines by some angle, these lines are going to be intersecting. So it's not a circle, but it's gonna, let's imagine it's a circle, going to intersect on this circle. But the problem is here, as we discussed last time, you're either going to continue to intersecting them on this side, or you're going to continue intersecting on that side. But according to the small example, you're allowed to have only one intersection point. And since you allow to have only one intersection point, you need kind of to take these 2 points and glue them together. And that's exactly what we got last time, that we got this kind of number 8, and we will keep gluing this number 8, and in the end, we're going to get a circle. So just as a summary, projective space, the idea is like to make the parent lines kind of to intersect. And it comes from ancient times, from the idea when you look at the horizon and kind of the road reach kind of singularity, the point right here. So that's why if you're going to take if you take any family of parallel lines, you just imagine that they intersect at the infinity, but you only need to have one point of intersection. You're only allowed to have one point of intersection. That's why you glue them. And that's how we got that RP1 is going to be a circle. Okay, so I'm done for this video. I will introduce a couple of more models, how to think about RP1, and then we actually can do some computations with RP1, and then move to RP2, and we will talk about real projective space. If you want to talk about anything else, also let me know, but first I want to cover this. Yeah, have a good day.